welcome colleagues in European Society for Periodical Research and those of you who are joining us especially for this session. My name is Peter Buse. I'm the Vice Chair of the European Society for Periodical Research and one of the organizers of this seminar series, which has been going on from about the middle of the pandemic. We decided this was a great way to ensure that we're meeting up and disseminating research in addition to our annual conference, the most recent one, which was held in September in Budapest, and the next one will be held in July in Leeds. So we have a topic today. As you can see, three colleagues who are working in the same area, an area which is of great interest to colleagues here in ESPRit. We had one of our keynotes in Budapest, which was focusing around this area, and it generated a lot of interest amongst colleagues. So as you see, that the topic of the seminar is new computational approaches to periodical studies. We have three speakers. They're going to speak for about 15 minutes each. We'll introduce each one of them before they start their part. But we'll have questions at the end because they're working on a project together, if I understand things correctly. So our first speaker is quite well known to ESPRit because Thomas was a nominee and a runner-up for the ESPRit Book Prize, the first one, the inaugural one in the recent year. And I'll just say a little bit more about Thomas so you know a little bit about him before he starts his talk. So Thomas is a postdoc researcher at the University of Antwerp in Belgium. He's an historian with an interest in visual culture and computer-assisted methodologies. Author of the book that I just mentioned, the prize nominated runner-up for our prize, The European Illustrated Press and the Emergence of a Transnational Visual Culture of the News, 1842 to 1870, published by Routledge in 2020. His recent work has been published in New Media and Society, Digital Scholarship in the Humanities, and Visual Communication, all of those excellent journals. So Thomas, I'm going to hand over to you now. Thanks so much for joining us here.
Thank you very much, Peter. So I hope everybody can hear me. Please let me know if it's not the case. So I will be speaking today, if my presentation works. Yes. So just before I start, it's also fun to be here because I just realized that my first presentation ever at the conference was at the ESPRit conference in 2014 in Nijmegen, where I did my PhD. So it's great to be sort of back here. So we'll be talking about today about our new project, Distant Viewing the Illustrated World of the Illustrated London News, 1842 to 1900. And as Peter already mentioned, this is a joint project, not by all of the speakers here, but definitely by two. So together, the project is a joint joint project of me and Ben, who will be the third speaker today, but also Paul Fife, which many of you might also know. Today, I first want to say something a little bit about the Illustrated London News. I guess it will be a familiar periodical to most of you. Then I want to say something about methodology, so how we can close and distant read the 19th century illustrated press. And then I want to go delve a little bit deeper into our new project. So first, I want to talk about how we use optical layout recognition to extract pictures from the Illustrated London News. I will keep this very short because it's mainly Ben's work. Then I will discuss how we can use multimodal machine learning to find patterns in the images that we extract from the Illustrated London News. And finally, how we can analyze these patterns. And I want to sort of close off with some conclusions because the work is at a very early stage, the project, and also with some future work that we're planning on doing in the next couple of months. On the 14th of May, 1842, the first issue of the Illustrated London News was published. And many scholars have argued that it sort of heralded the age of the visual mass medium, right? So it's often seen as the first visual mass medium, definitely of the 19th century. And I'm of the same opinion. Its main innovation was that it sort of combined words and images. So it followed the news in words and images and also on the same page. It quickly became a huge success and a staple of Victorian life. It sold in the 1860s, sold many 100,000 copies a week. I think in my previous book, I sort of tried to argue that despite its title, which of course refers to London, it's very much an imperial or transnational periodical. So readers could not only be found in London, but also in the rest of the UK, all the corners of the British Empire, but also in other countries such as the United States and countries in Europe. And I think we can sort of say that it has had a very transnational distribution, which we can sort of compare to the New York Times, right? Also has New York in its title, but it's very transnational, or Time magazine. So it's probably the most well-known illustrated newspaper, but definitely not the only one, right? So we have other British competitors, the Illustrated Times of Henry Fusatelli, the Graphic in Europe. We have the L'Illustration in France, but also the Illustrierte Zeitung in what was then the German state of Saxon. And in America, we have Frank Leslie's illustrated newspaper. So we have all these different titles that are sort of comparable in form and content. So I think the Illustrated London News has generated a lot of interest from researchers because it's sort of a window, a visual window on 19th century or Victorian Britain, right? And researchers have sort of analyzed its pages to study British identity. I think most notably Peter Cinema, but also the representation of the British Empire, the visual representation of all sorts of new technologies, such as one of my favorite articles by Paul about the visual representation of the railway in the Illustrated London News, but also many other topics. So what I always found interesting that this sort of, while the visual world of the Illustrated London News was very much marked by the sheer number of illustrations it sort of published, the majority of these studies depend on a very close reading of a select number of illustrations of the periodical, right? So what we sort of see as close reading depends very much on the researcher. It's often not a very well-defined methodology. I think it often emphasizes uniqueness, or it generalizes or draws general conclusions from a very small sample. And as I mentioned, this is sort of stands in contrast to the large number of illustrations that you can actually find in the Illustrated London News. So I've made a small estimate that between 1842 and 1900, we have roughly 80,000 illustrations, but it's probably a low estimate, so it's probably more. So instead of generalizing or drawing general conclusions from a small sample of images, we can also test hypotheses in these images, or that's sort of the idea of this new methodology, which has been described by my colleagues Lauren Tilton and Taylor Arnold as distant viewing. So instead of close reading, we have distant viewing. So distant viewing, of course, comes from distant reading, which was developed by the literary scholar Franco Moretti, or it was more or less proposed by him, not very much developed. And it's sort of the method uses computational methods to find patterns in a very large data set. And until recently, that was very hard to do for images. So it was a very well-known methodology for text, because we had all these sort of techniques which could be used for that, right? For example, topic modeling, which some of you might be familiar with. But we had no comparable methods or methodologies for images. However, in the sort of the last 10 to 5 years, we saw the development of computer vision methods, which we know from self-driving cars and facial recognition, that sort of stuff. And historians and other scholars have sort of tried to apply these methods also to visual collections of visual historical documents, right? So one of the main problems of these computer vision techniques was that they displayed what I've called earlier in an article with my colleague Melvin Wevers, sort of an historical bias. So these methods were all trained on, so they are all AI, right? So they are all machine learning methods, and they were trained on huge data sets of high definition photographs, which were mainly extracted from the internet. And because of that, they did not perform very well, as computer scientists like to call it, on non-photographic material. So they were very hard to apply to something like the illustrations of the Illustrated London News. And this is also something that Paul Fife and Kay have sort of shown in their 2018 article in Cultural Analytics. So it's called Image Analytics, the article. So what I want to sort of show here today is that we can use a new type of machine learning called multimodal machine learning to sort of indeed distant view the illustrations of the Illustrated London News. First of all, we have to start by extracting the illustrations from the digitized periodicals, but I will mainly leave this for Ben, because it's also his work. But what we can basically do is use Ben's trained model to extract these illustrations from the pages of any illustrated periodical. So here I've applied it to the pages of the Illustrierte Zeitung, and you can see that it works pretty well. This small side note, I know that the many scholars of the Illustrated London News, such as Tom Grattan, but also Andreas Beck in Germany, have been very interested in the sort of the layout of the illustrated newspapers. You can also use these new object detection models to sort of see what the relationship is between a written word and text or image, sorry. So I will first now sort of explain how these multimodal models work and then how we can apply them to the Illustrated London News. So this is going to be a little bit technical, so please bear with me. I think so. Multimodal machine learning basically means that the machine learning is not only trained on one mode, so on either images or text, but on both images and text at the same time, right? That's why it's called multimodal. And what it basically does is that the multimodal model learns visual concepts from what computer scientists like to call natural language, which basically mean that they have not labeled this language. So in our project, we are mainly using a model called CLIP, which was developed by this company called OpenAI, now very well known for another invention of theirs, the infamous chat GTP, sorry, not GTP3, GTP. So CLIP is basically a multimodal model which was trained on 400 million image-text combinations, which were all sourced from the internet. So that's a very high number. And the original task of the model, so what it needs to learn to do, is that it needs to predict the original pair. So given an image, it needs to predict the relevant caption, and given a caption, it must predict the relevant image. And in order to perform this task for the sort of technically inclined amongst you, the model has to learn to place the text and the image very close to each other in the embedding space, as it is called. And because CLIP has become very good at this task, we can use it for all sorts of very interesting tasks in the humanities, or at least that's sort of what our project also intends to show. So what it can do is it can perform all sorts of prediction tasks without the need for any labeled data. So we don't have to give it labeled data, which saves a lot of time. And we also don't have to train it for specific tasks, for example, to find a cat or a dog or a car or whatever. And this is what computer science call that it has a very high performance in the wild. So that means for tasks for which it was not trained, in effect. But what is more important for our project is that because CLIP is trained on image text pairs from the internet, so not only on photographic material, but on all sorts of visual media, it also shows a very high performance on non-photographic and heterogeneous data. So that's also why we thought that we could apply it to the illustrations of the Illustrated London News. So we can use it for all sorts of very traditional tasks. So this is a sort of a task where we try to match images. So basically use CLIP to find the same images in a large data set. And these are all images from the Illustrated London News, the Illustrierte Zeitung, and l'Illustration of the Revolution year 1848. So here I was sort of basically looking if we could use CLIP to automatically find the same images and also automatically find the sort of chart the recirculation of these images. And you can see that the model is indeed very good at this. So it can very easily find the same images in a large data set. It not only finds the exact same images, but it also finds, it's very good at finding similar images. So here you can see that these are two images. One is from the Illustrierte Zeitung and one is from the Illustrated London News. And they are, of course, two different images, but they show the same building, namely the Hotel de Ville in Paris. So here you can sort of see that it has picked up the model that these two buildings are similar, which I thought was very interesting. But what the main advantage is of CLIP is not only that we can sort of use it to find the same or similar images, but that we can in fact use it as a sort of a visual search engine. So what we can do is instead of, we can give CLIP any prompt, so a textual prompt, for example, an image of a revolution or an image of a barricade or an image of the army. And then Clip, because it's very good at predicting relevant image text combinations, it will find these images for us in our data set. So these are a couple of examples from a paper which Ben, Paul, and I have just submitted, which will hopefully be accepted in the next couple of days. But here you can see that we used it for, we had a small or around 1,000 images from the Illustrated London News, and here we use Clip to find images of steamships in the sample, but we can also use it to find more complex visual concepts such as these. So here we use it for a prompt, an image of the army. And finally, we can also use it to find a specific type of image. So here we use Clip with the prompt a map, and then these images showed up. So now to some conclusions. I hope I'm still on time because I forgot to set my timer, but I hope I'm still okay for some conclusions. So what I think that Clip can do, or multimodal models in general can do, is that they can act as a sort of a visual search engine. So they can in fact sort of find any visual concept in these 80,000 images of the Illustrated London News. So in the illustrated world of this periodical, which I think is very fascinating. And I think this sort of works similarly to keyword search, right? So how sort of optical character recognition sort of revolutionized periodical research as described by Bob Nicholson in 2013. We can now do the same for images than we earlier did for text. So I think that in this sense, multimodal models have sort of the potential to revolutionize research, especially in the visual side of periodical research. Well, but they cannot only be used to find sort of these needles in a haystack, right? To find a specific visual concept or image in a large number of images, but they can also be used to detect patterns. And here I think they can shed a new and also more sort of a better or more representative light on old questions. For example, the visual representation of the railway, right? So we can use Clip to find all the representations of the railway in the ELN. But we can also, and this is where our project hopes to go, use it to find sort of shed light on new questions. And here we are mainly focusing right now on two questions. So we first want to look at the imperial, what we have called imperial geography of the ELN. So here we will sort of look for all the maps that the periodical published. And then we try to make a sort of a map of the world according to the Illustrated London News, or at least that's the idea. And we also plan to use it to study political representation. So, for example, what does a politician look like in the Illustrated London News? So that was basically it. So we will take questions at the end, but thank you very much.
Okay, it says I'm viewing Kaspar's screen, so I think I'll just carry on. So welcome, Kaspar. Kaspar's a research associate at the Alan Turing Institute in London, where he works for the Living with Machines project. So Kaspar, over to you.
Thank you. So I'm very excited to be here and talk to experts in periodicals. It's the first time actually I do this. So my presentation is called Mining Victorian Metadata. And basically what I would like to argue in this paper is how we can use press directories. Some of you might know them, but I will introduce them a bit more in detail. How we can do a distant viewing, a distant reading of press directories, and what this might learn us about the evolution of newspaper in the press. So the overview of this talk, I will quickly give some context about the project I'm working on and also the digitization of the data, the press directories. And then I will show two main applications of how we are using those directories for actual research. So I'm working for the Living with Machines project, which is quite a big project. It's mainly a collaboration between the Alan Turing Institute and the British Library, with many partner institutes. And we are quite a large interdisciplinary team, like mainly tackling, the main question is how the project is mainly an inquiry into how technology impacted the lives of ordinary people during the machine age or the industrial revolutions. But it has this kind of double angle. So it wants to know how machines kind of permeated everyday life during the 19th century, but also how today historians can make use of machines of today, like how does AI and data science shape the analysis of the past. And one thing what we are doing at the moment is exploring those large collections, maps and census, but also newspapers. And so I will talk about how we use press directories and to make more sense of the newspaper collection, because this is still a challenge in history. Like we have lots of data, but still we don't really know how to interrogate it critically. How do you actually analyze or make sense of a corpus that consists of 100 billions of words? And my main answer to this, and what I like to argue, is that by contextualizing big data, we can actually make it much more useful for historical research. And I'm especially interested in contextualizing data using the categories that are kind of time specific. So how was the press described in the 19th century, and how can we use those categories for analyzing the press digitally? So the main thing of how we went about contextualizing the newspaper corpus was using a source called newspaper press directories. And some of you might know them. So basically there were, this source we use is called Mitchell's newspaper press directories. And it appeared almost annually from 1846. And it was kind of a record of most of the, it claimed to be kind of quite exhaustive list of newspapers circulating in Britain. So what you can see with its content, so for each newspaper, it would kind of give a short profile. So it would tell you the place of publication, but also like what is the political leaning of this paper, what are the places it aims to circulate. There's also some information about proprietors and price, and some kind of open text. So it kind of has some short descriptions. So this paper, the Chatham News, is independent, and it's described as advocates local interest and so more. So it's quite a rich profile of a newspaper, and these were published annually almost annually from 1846 forward. So what we did in the Living with Machines project is try to digitize those. So those were scanned by the British Library, and what we try to do then is try to convert those images to, let's say, a format which is more easy to work with for historians. So basically what we did is to get the image and then transform this image to like a table, basically. So you can see we go from image to let's say more from this image we would extract the title of the newspaper, the place, and the politics. So this is a much more easier way to kind of work with for historians. And just to give you we spent quite some time on doing this quite carefully, because Thomas also discussed it, that much of machine learning tools have like a bias that they work well on the data of today, but not on historical data. And the same goes when you want like to convert like an image to text. Like most of the standard software really has problems doing this. So what we did actually is like to recreate a whole pipeline that goes from the image to the structured format, but at each stage we would try to adapt our tools to the historical particularity of the data. So we wouldn't just use a normal kind of software to convert the image to text. We would use something that particularly was trained on converting it for historical data. And this worked quite well. So originally we used Abbey Fine Reader, which is quite a famous tool for converting image to text, which is shown on the left here. And you can see actually it really kind of fails to convert it well. So our pipeline, which was adapted to the directory data, worked much better. So in this way, we ended up with like really high quality version of the historical press directories. And the good news is that these are like partly available now. So there's a demo version available on GitHub. I show the link here. And this demo version contains 46,000 records of like 46,000 descriptions of newspapers between 1846 and 1920. And besides those, and we also extracted from those descriptions the politics and the place and price. So they're kind of available to you to work with. They're in spreadsheet format. So you don't have to be a digital historian to use them. You can just load them in Excel and start searching for them. And the original text and XML is also available on the BL repository if you would like to use it. But soon we will release an even better version of 90,000 records. So stay tuned. But you can already play with the version we have released. So now more to the meat of this presentation, like how can we actually use those directories? And I would like to make here the argument that those directories are actually quite an interesting and important source by themselves. So they've been often used as reference work. So if people would like to know something about the newspaper, they would go to Mitchell's and find the description. So it's a bit like extractive use, but I think, and also I'm supported here by other O'Malley and Brake, that these directories are quite interesting cultural resources as well. They merit studying them as a source by themselves because they can tell us something about the press. So one thing I've been looking at so far is how can we use the directories to better understand how Victorians, in this case Mitchell, classified the press, and how should we understand the classifications that were used in the directories. So one preliminary analysis I did, which was actually really simple, that I looked at the political labels in those directories and tried to kind of extract the meaning of those labels through an analysis of the press directory. So one thing I was interested in, like how stable are these political affiliations? So each newspaper claims it's liberal, but actually how stable, what does it mean to be a liberal newspaper? This was one of my questions I did. So one thing, what I like to do was very simple, again, to just look how many labels did appear in the press directories overall. So in total, I found almost 200 different labels. So it shows also like some of them are very frequent, of course, but actually it also shows like a quite interesting, that newspapers were quite interested, like really refining their position politically in the press directory. So they use a wide and very nuanced form of labeling. And what we also did, we have those records for the newspapers. So for each year, we have like one record, and then we can also link them over time. So you can see how a newspaper developed over time as it was recorded in those directories. And one thing I also did then, like how often do those newspapers actually change their political label? And actually, so far I found actually it happens rather often, like in 1 in 5 newspapers change their political label over time. So they are not like very fixed. They're like quite, the landscape is more fluent as one might often, and as I expected. And this shows you the most frequent transitions that happen. So for example, there's this kind of category of independent and neutral, and you can see that the newspapers move along those labels, mostly moving from liberal to independent or independent to conservative. They don't move often from liberal to conservative straight away, but it shows you how this landscape kind of changes, how those labels give them a positioning in the political spectrum. For example, you can also see how often newspapers move to the right or to the left over press. And I will skip this part. There's one more thing I want to talk about, is how we use the newspapers also as a critical resource to better understand the digitized corpus. So what we have, so newspapers are being digitized very, very, very rapidly at the moment, but still you can still think of the digital newspaper as a sample of a wider population of newspapers. And the problem is that we often really don't know. So for example, the corpus I've been working with, the British Newspaper Archive, it's gigantic. It has more than 100 billion words. But still, like, we actually don't really know what's in there, and how this corpus actually came to be, and actually how it kind of might deform our findings. So we are a bit like, it's a very big pool, but a very opaque pool of information. And one thing we were doing in living with machines is using the press directories to kind of shed more light on how these big digital corpora are formed, what they contain, and also what biases they may contain. And this figure shows you a bit how when you work with newspapers, when you work with digital newspapers, this is kind of what it looks like. You have like a big landscape of newspapers, and what you can actually search are the digital ones. It's just a small sample of this. So we would like to better understand how does this sample relate to this landscape of newspapers. So the question we tried to address, and we mainly, for now, what we did, we focused mostly on the provincial press because we thought it was more interesting. It's still like less understood, it's less well known. So we tried to look at specific corpus of JISC newspapers. And we were actually interested, like, is this corpus representative of the newspaper landscape? Is it representative of the population of newspapers? And not as a critique, but just like to show how doing this can give you more kind of critical leverage when you work with a corpus. For example, this shows you one graph we made. So we kind of compare the proportion of the blue line shows the proportion of conservative papers, and the blue line with squares shows you the proportion of conservative papers as was recorded in Mitchell. So in Mitchell, in 1846, 40% of the papers were conservative. But if you look at let's say the digitized corpus, there were actually more. So you could say that the digital version, the conserved papers were kind of overrepresented. And we applied this to different categories, and what we found about was quite interesting. And in this specific case study, is that we kind of see generally that like partisan papers are overrepresented. So this is, and while the neutral and independent press, which actually often give more a local perspective, or tend to be like more absent in those papers. So it kind of shows that corpora could be more like a reflection of let's say the priorities of historians today, and maybe less what people read in the 19th century. Because we know that these neutral independent papers are actually very, and these provincial papers are actually very, very, very popular. So again, this is just so to show you how you could use those directories to more critically engage with the big data corpus. And we have done the same with like price. We have looked at our expensive papers overrepresented in this corpus, and we again found that generally, yes, that there was like the papers that were digitized and tend to be more expensive. So again, this is then not meant as a criticism on the corpus, but I think as historians should know that what you find is probably biased by certain types of information. And yeah, you can read in more detail the analysis in this paper which we just published. And there's also a link to the GitHub repository where you can find the data as well, which we used for this analysis.
Okay, so our final speaker is Ben Lee. Ben is a fifth-year PhD candidate in the Paul G. Allen School for Computer Science and Engineering at the University of Washington, where he's a National Science Foundation Graduate Research Fellow in Machine Learning. He served as the 2020 Innovator in Residence at the Library of Congress. Ben, welcome, and over to you.
Thank you so much. And I want to start just before getting underway to thank Thomas and Kaspar in particular for collectively sharing our work on computational periodicals. And a lot of this work hopefully will have a lot of through lines, and I'm looking forward to the discussion phase in particular. Just want to preface this also by mentioning that the project that I'll be sharing a little bit about for the next 15 minutes or so, Newspaper Navigator, started with the Library of Congress through the Innovator in Residence program. And I'd like to, in particular, thank the LC Labs team, the National Digital Newspaper Program, and IT Design and Development at the library for making this possible. And of course, this project all has been undertaken as part of my dissertation in computer science at the Paul G. Allen School for Computer Science and Engineering. But with that, let me go ahead and give an outline of the next 12 to 15 minutes or so. And the goal here is to take sort of three approaches of the project and take a look at first, the data set of extracting visual content. Second, turning to the question of how we actually search over this visual content. There will be a number of resonances here with the project with Thomas as well. And then lastly, turning to, in conversation with the environmental scan work of Kaspar's, thinking through how we sort of trace these digitization flows from a more critical socio-technical perspective. And then, of course, we'll move on to questions. So let me go ahead and motivate this work through the lens of the newspaper collection on which Newspaper Navigator is built, which is known as Chronicling America. And so it's a database of about now over 20 million digitized historic newspaper pages from across the United States. Generally speaking, this content is contributed from states and territories across the United States and from libraries and other donors. And it's produced by the National Digital Newspaper Program, which is this joint partnership between the National Endowment for the Humanities and the Library of Congress. Notably, all of the pages are in the public domain, making it this really vast resource for public use and reuse. And moreover, it supports full API bulk data access. I'm particularly thankful to the initiatives taken to make this data set really fully accessible from a computational perspective as well. My project Newspaper Navigator really draws heavily from a crowdsourcing initiative launched by the Library of Congress Labs team in 2017, known as Beyond Words. And the goal of this project was to engage the American public through the really rich visual content or visual culture in these newspaper pages from the World War I era by asking volunteers to draw bounding boxes around 5 different types of visual content. And this included photos, illustrations, maps, comics, and editorial cartoons. And this initiative was really quite successful. It had accrued thousands of annotations before the project ended. And I encountered this soon after it had launched and was really captivated by the visual content embedded within, and that had been surfaced by some of the volunteers. And so what I became interested in asking was, seeing the success of this project, wondering if we could somehow build on these annotations produced by the Beyond Words volunteers to try to train a machine learning model to extract this visual content at scale. And so, to borrow some language from the Library of Congress's digital strategy, the goal here was to ask whether we could, quote unquote, throw open this treasure chest by doing precisely this across the scale of millions of pages. And so the general goal of Newspaper Navigator then became, starting with these full newspaper images, if we could start with the raw image and then end up with a fully articulated search interface over the extracted visual content, not just providing sort of keyword search over the captions, but new modes of, say, visual similarity search as well. So let me go ahead and start just by motivating this through the data set itself. So the goal here was, if we have newspaper pages, we'd like to be able to feed them into a machine learning model that will not only return us bounding boxes showing where the visual content is located, but also classify it according to these 7 different categories, the 5 categories from the Beyond Words project, plus these additional categories of headlines and advertisements. Then we can actually utilize the underlying optical character recognition, or OCR, to extract the text falling within each bounding box, with the idea being here that this gives us the actual underlying headline, or in the case of an image, it will give us some idea of a caption. And so now we have some initial textual metadata describing all these bits of visual content as well. And so I'm going to gloss over the actual training of this model just in the interest of time. I'll have some resources for a bit more on the sort of technical component of this. But I do just want to show some example newspaper pages from a held out set when fed to this fine-tuned machine learning model to give a sense of what the performance looks like. So in the top left of each bounding box, we find the predicted class of one of those 7 classes, along with a confidence score. And what we find is that the model really does quite a good job. Pretty much all of the headlines are identified. The advertisements are segmented out properly. We find that photographs are identified as such. Comic strips are being preserved rather than having each individual cell being segmented out. Of course, we'll have cases where there might be redundant bounding boxes or missing bounding boxes. But overall, it seemed like, at least at this stage of the project, that the model performance was high enough that we could really think about performing this at scale and then serving a downstream data set that would be useful to researchers. And so to walk through what the pipeline looked like, the idea was to really leverage the Chronicling America bulk data access to download each newspaper page as a high resolution scan, along with the corresponding OCR. We can then run this visual content recognition model on the page and crop and save out all of the relevant visual content. We can then go into the OCR and extract the relevant captions for each bit of visual content, generate image embeddings, which will be useful for the visual similarity tasks, and then lastly, save all of this. So this gives us really one way of processing a single newspaper page. And then the question of the project really became how we do this at scale at the time across all of the 16.3 million pages available. And so much of the sort of code development throughout the spring of 2020 was devoted to this aspect of the project. So in total, we were able to process about 16.368 million Chronicling America pages. This amounted to probably about 99.998% of the available pages at the time. This amounted to about 100 terabytes of image and XML data. And this took about 19 days of training across these 8 AWS EC2 instances that amounted to about 96 CPU cores and 8 NVIDIA T4 GPUs. But I do just want to go ahead and give one sense of what the data set actually looks like, because I think it contextualizes it or gives it some intuition, and I think it's also fun. So one of the sort of questions that we encountered throughout the creation of the data set was speaking with staff members and other researchers who had very specific use cases. And one that came up was really trying to, say, isolate specific kinds of visual content, such as maps of the American Civil War. And previously, this would require really manually going through tens of thousands of newspaper pages and cropping out all of the visual content that would be relevant. But with the data set, it's actually quite straightforward. We can provide a simple query where we grab all of the maps from 1861 to 1865. And if we zoom in, we'll see that these are all pretty much maps of the Civil War. And I do want to mention, of course, there's utility here for historians of the Civil War, historians of cartography, but we can also begin to perform some distant viewing as well. And you'll notice that there are a number of advertisements that are being that appear multiple times here, not because they're being identified redundantly by the model, but rather because they're actually being recirculated. And so sort of akin to the viral text project that I love by Ryan Cordell and David Smith, we can actually begin to sort of infer this network structure or the virality of maps or other bits of visual culture as well. So in terms of some resources for the data set, if you visit news-navigator.labs.loc.gov, you'll find the full Newspaper Navigator data set, which you can query computationally using HTTPS or S3 requests. We also have a bunch of prepackaged data sets, making it possible to download, say, all the maps from a given year, all the photos from 1922 in a zip format, and then grab metadata in JSON or CSV format as well. We have a lot of all of the annotations formatted in a sort of object detection standard to make it possible to use as training data, along with all of the code in the GitHub repo as well. So this includes Jupyter notebooks for running the code, training the model, running the pipeline, etc. And lastly, I did want to just mention a pointer to a more technical paper that we presented at the Conference on Information Knowledge and Management in 2020, which goes into a bit more detail sort of in the training and performance of this model if you're interested. And lastly, I'll wrap up this portion by mentioning that all of this is in the public domain, from the data set to the underlying code, and sort of per the Library of Congress's mission here, there's a goal of really emphasizing use and reuse wherever possible. With that, and these next two sections are a bit shorter, I do just want to go ahead and turn to the questions of what we do once we extract this visual content. With the idea being, of course, it's great to be able to download these prepackaged data sets, but it would also be really beneficial to individual researchers to provide new modes of search and discovery. And so the idea behind the Newspaper Navigator search app interface was to provide this new mode of searching over about 1.5 million photos from the data set. And so the idea here is to go beyond just sort of standard keyword search and also empower users to train AI navigators to retrieve visually similar content. And here again, you'll notice a number of resonances with the work that Thomas presented as well. And the idea here is to expose machine learning training to the user, where the performance is quite responsive. Training and predicting is nearly instantaneous. But I want to go ahead and motivate why we might want to be able to do this kind of visual similarity search. So if you visit the search application, you might do a keyword search against some of the text associated with an image, that we roughly assume to be the caption. And we see that, this is a great way of accessing the materials. If we do a keyword search for baseball, we find a number of related images being populated, and we see that there are about 5,400 results. But we also notice, of course, many of the limitations of this kind of approach. We know that OCR is never perfect. Also, captions are never a full description of an image's content, right? We know that there are many related images that might just not have the specific phrase in the underlying caption. So this means that being able to do some sort of visual similarity search or visual retrieval could be quite beneficial. And so in the search application, we surface what I call an interactive machine learning interface, where on the top left, we can steer this AI navigator, as I call it, toward the images in green and away from the images on the bottom left in blue. And on the right-hand side, what we find are the predictions coming back from the model being ranked according to what is most like the sort of baseball player idea on the top left. And none of these images on the right necessarily have the relevant captions. This is being done entirely based on the visual content embedded within. And we find that this, is a new way of basically being able to query the data set. And so here's an example from sailboats as well. And I will mention that the search application is still live. We launched it publicly in September of 2020, and you can access it here at news-navigator.labs.loc.gov/search. And with that, in the last couple of minutes here, I do just want to wrap up with the question of really understanding how Newspaper Navigator is sort of embedded within these broader socio-technical systems, and understanding it through the perspectives of microfilm, digitization, ingestion into this of course massive undertaking of Chronicling America, and then finally to being ingested in the Newspaper Navigator as well. And so to really study all these different steps and understanding how they mediate search and discovery, I studied these 4 different photos of W.E.B. Du Bois reprinted in Black newspapers in Chronicling America. And the idea here was to really start with the physical newspaper pages, understanding what happens as they're then, what's selected to be digitized, very similar to what Kaspar has mentioned as a really important question to be asked of these kinds of digitized collections. Understanding that how they're microfilmed, how the underlying images might be saturated. We see here, of course, the image on the far left is almost unrecognizable due to the sort of condition of microfilming. Then brought into Chronicling America, decontextualized into the Newspaper Navigator data set. We find that the underlying OCR is never perfect. The visual retrieval is never perfect as well. And so I think these are all very much important steps as we really think about these kinds of computational approaches to also recognize the limitations and the importance of these sort of computational, close readings and other methodologies as well. And I'll mention that this piece that I wrote is what I call a data archaeology. And so it recently appeared in a Digital Humanities Quarterly. But with that, I do just want to wrap up and mention, of course, some of the relevant resource links as well. I'm happy to put any in the chat if anybody would find that helpful. But with that, I'll just go ahead and wrap up with some acknowledgements. First and foremost, thanking Thomas and Kaspar for the opportunity to be here. Then my advisor, Professor Daniel Weld at the University of Washington and the Allen Institute for Artificial Intelligence for really giving so much guidance and steering this project. All of my collaborators at the Library of Congress and external collaborators as well. And this research is based upon work supported by the National Science Foundation Graduate Research Fellowship and the Library of Congress Innovator in Residence position. And with that, I will go ahead and turn it back over to Peter, and I'm excited for the discussion phase here.